Number 7 here, I'm going to set up a scatter plot essentially. So I'm just going to plot each of these values. So I'm going to put my age down here. I'm going to put the M&Ms over here. So the age, I got to start somewhere around 6 and get somewhere to around 26. So I'm going to do 6, 8, just counting by 2s. For the M&Ms, I got to start somewhere around 7. So maybe I'll start here at like 5. And now I'm just going to plot each of these values. So let's see, I've got 7, 5, or sorry, 6, 7. Right around here. 10, 22. 1430, 1833, 2232, sorry, it's actually a little off here. 1833 is right about here. 2032 is down here a little bit. And then 2628 right around here. Okay, so when I look at this thing, it looks like it's forming some kind of a parabola. So if I wanted to draw a curve of best fit, it would look something like this. I would draw essentially a parabola here. To find the equation for this one, we're going to do this guy on the calculator. So let me pull my calculator up and show you how to do this. What we do here is we're going to plug this into our calculator. And the first thing we need to do is we need to go to Stat, and then we hit the Edit button, the very first option. And it should bring us to this List 1, List 2 thing. And you can see I've already done this once. But I'm just going to go up. If you have something in your list, you go so that L2 is highlighted, hit Clear, back down into List. Same thing with L1. And then essentially I'm just going to put my X values into List 1. Starts at 6. 10, 14, so I'm just going to plug those values in. So we've got a 6, 10, 14, 18, 22, and the 26. And again, I don't plug in the 35 because I don't have a Y value that goes with it. So then I punch in the Y values that go with each of these. There's a 7, I can't see it, my calculator's covering it up, but it's there. 22, the 30, the 33, the 32, and the 28. So now I have these punched in. Essentially, I've taken my horizontal table, I've plugged it in vertically, and now I go to Stat again, over to Calculate, and I want to come up with a best fit curve that's a quadratic, so I want to do number 5, which is a quadratic regression. And then here you either hit Enter again, or you go down to Calculate and hit Enter one more time. And what it does is it gives us this equation in terms of A, B, and C, if I can scoot this off to the side as far as I can. So I get y equals a negative 0.15x squared plus 5.66x minus 21.04. Okay? So this is my best fit equation, the best fit line, or sorry, the best fit curve that I have here. So that's my prediction equation. That's one thing it asked for. And now it also asked me to predict this value of 35. So I essentially just go back and plug this into my calculator. And when I do that, it gives me approximately a negative 6.69, something like that. And so when we look at this in the context, this is how many M&Ms I'm going to eat in one sitting as we get older. So it looks like I've replaced my M&Ms with P's. I think that would be a negative version of an M&M. So we get a negative 6.69. Okay? For the next couple, it says to list the number and type of solutions. And for this, when we just want to know the number and type of solutions, we do b squared minus 4ac. We use our discriminant. Okay? So for this first one, if I'm using the discriminant for this guy, I do b squared, which is the 6 squared minus 4 times a, which is 1, times c, which is an 8. So that's 36 minus 32, which is a 4. When my discriminant is a perfect square, it means I get 2 rational solutions. Okay? I do the same thing with the next one, the b squared, so negative 4 squared minus 4 times a, which is 1, times c, which is a 4. So I get 16 minus 16, which is 0. When my discriminant is 0, it means I'm going to get 1 rational solution. And then number 10, again, I'm doing the discriminant b squared minus 4 times a, which is 1, times c, which is a 5. So that's a 9 minus 20, which is a negative 11. When I get a negative value for my discriminant, it means I'm going to get imaginary numbers, which means I have 2 complex solutions. Okay? And then number 11 is a continuation of these. It says which solution type is not listed above and what value the discriminant would yield that solution type. So I've got 2 rational, 1 rational, 2 complex. The one that's missing is 2 irrational solutions. And I get 2 irrational solutions when my discriminant is a positive that is not a perfect square. Okay? An example of that would be something like a 5 would be an example of a positive that's not a perfect square, would give me 2 irrational solutions. Okay? For the next couple, we're just solving each of these. First method I always want to check for when I'm solving is factoring. So this first one, I'm going to subtract the 9x from each side. I always like to get everything on the same side first to see if factoring works. So I get 3x squared minus 9x equals 0. And this one can be factored. I factor out the greatest common factor, factor the 3 out, leaves me with an x minus 3. And then I set each factor equal to 0. The 3x equals 0, the x minus 3 equals 0, and I solve each. This first one, I divide each side by the 3, so I find out that x equals 0. The next one, I add the 3, so I find out that x equals 3. So my 2 solutions here are x equals 0 and 3. And that's it. In number 13, the first thing I do, again, I check to see if it can be factored. I build a bridge, 2 numbers that multiply to a 6 but add to a 4. It's not going to happen. Okay, which means this one can't be factored, so I go to something like completing the square or my quadratic formula. For this one, I can't, so I'll go to something like completing the square or my quadratic formula. For this one, I can use my quadratic formula because I've got an a value of 1 and a b value that's even, and those are the perfect conditions for this. So I'm going to subtract the 6 from each side. That's going to give me an x squared plus 4x with a little space equals a negative 6. And now I complete the square. I take that middle term, the 4, I divide it by 2, and I square it. So I've got 2 squared, which is 4. So the missing term that I need here is a 4. So I put a plus 4 here. Whatever I do to one side, I have to do to the other side. Now I factor this thing. That's x plus 2 squared. That's why I created a perfect square trinomial of 1 and something squared equals a negative 2. And now I can take the square root of each side using my square root property. So I get x plus 2 equals plus or minus because I took the square root of each side. And now the square root of a negative, I can take an I out, so I get I root 2. And now the last step here, I subtract the 2 from each side. And this gives me 2 complex solutions, negative 2 plus or minus I root 2. And I'm going to leave it just like that. Okay? And that's it. Number 14, there's a couple options here. Since it's set up this way, I'm just going to solve it by factoring. This is a difference of squares, factors into an x plus 8 and an x minus 8. And now I can set each factor equal to 0. And I solve each. Here I subtract the 8 from each side, so I find out that x equals a negative 8. Here I add the 8 to each side, so I find out that x equals a positive 8. So I get 2 solutions here, negative 8 and positive 8. And just remember, I could have added the 64 to each side and taken the square root. I just have to remember to do plus or minus when I do that to get my 2 answers. Okay? Number 15, the first thing I might try is to subtract the 3 from each side, just to see what this looks like. So I get x squared plus 4x minus 3 equals 0. And then I might check to see if I can factor it, two numbers that multiply to a -3 but add to a +4. Doesn't look like that's going to happen, okay? So this one, I would probably either do completing the square of the quadratic formula. In fact, for this one, I would definitely do completing the square. However, many of you might not like completing the square, so I'll do the quadratic formula for this one just to show you how much simplifying you'll have to do in the event that you get a problem like this. So I do the opposite of b plus or minus the square root of b squared minus 4 times a, which is 1, times c, which is a -3, all over 2 times a, which is the 1. And now I continue to simplify. -4 plus or minus the square root of 16 plus 12 all over 2. I continue to simplify. -4 plus or minus the square root of 28 over 2. And now from here, the square root of 28 I'm going to have to break down. Because there's perfect squares in there, I can break this down to a 4 times 7. The square root of 4 is a 2, so this becomes a -4 plus or minus 2 root 7 over 2. And now everything's divisible by 2. This whole thing's going to simplify to a -2 plus or minus the square root of 7. Okay? So there's a lot of simplifying involved when you do this by the quadratic formula. If you do completing the square here, a little bit less work in terms of simplifying. Okay? So keep that in mind. For this one, again, the first thing I always check is factoring. I build a bridge. That's a -12. Two numbers that multiply to a -12 but add to a -1 are -4 and a +3. So this one can be factored. I can't use my shortcut this time, so I split up the middle term. And I factor by grouping. Group the first two together, group the second two together. Out of the first two, I can factor out a 2x, which leaves me with an x minus 2. Second two, I can factor out a 3, which leaves me with an x minus 2. So now my two factors are the x minus 2 and the 2x plus 3. And now I set each factor equal to 0. I do x minus 2 equals 0. I do the 2x plus 3 equals 0. And I solve each. Here I'm adding the 2 to each side, so I get x equals 2. Here I subtract the 3 from each side, so I get 2x equals a -3. And then I divide by the 2. So I end up with two answers here. An x equals 2 and an x equals a -3/2. Okay? Number 17, last one for solving. First thing I check, building a bridge. Two numbers that multiply to a -10 but add to a +1. Not going to happen. All right? And for this one, I can either use completing the square of the quadratic formula. I wouldn't recommend completing the square because I don't have an a value that's 1. I don't have the b value that's even. So this one I'm going to use my quadratic formula. Opposite of b plus or minus the square root of b squared minus 4 times a times c. All over 2 times a. That's a -1 plus or minus the square root of 1 plus 40. All over 2. So I get -1 plus or minus the square root of 41 over 2. Which that's it. I can't simplify that any further. Those are my two x values. Okay? I get these two irrational solutions, and that's it. All right?